right, today we're going to be continuing our lesson on exponent laws or exponent rules, and our EQ for today is going to be the same as our EQ for yesterday, so you can even just continue these notes right on the next page after the ones that we did yesterday. So just title it again, exponent rules. EQ again, how do I apply exponent rules to simplify expressions involving exponents? Hit pause and set up your notes for today. When you're ready to move on to the notes, hit play. All right, so yesterday we talked about what we call the product rule and the quotient rule. In the laws of exponents, we talked about when you multiply exponents with the same base, you add their exponents. When you divide with powers with the same base, you subtract their exponents. So today we're going to learn two more exponent laws called power to a power and zero power property. And this is going to be it for our exponents unit. It's a very short, just 2-day unit. Okay. All right, let's review from yesterday. What did we do when we are multiplying two terms that have the same base as exponents? If they have the same base, then we keep that as the base and we add the exponents. So 3 plus 6 is going to give us a to the 9th power. What will we do for number 2? Same thing. Do they have the same base? Yes, they do. So W is our base. We add the exponents. What's 8 plus 4? It will be W to the 12th power. Okay? So that's review. We call that the product rule. All right. Next, let's practice the quotient rule that we learned yesterday. Again, we check and see, do they have the same base? A. So the base is A. And what do we do with those exponents? We subtract them. 4 minus 9. We did this one yesterday. Remember, we had to draw a T-chart. 4 is positive. 9 is negative. We bring over the smaller number, and we subtract. It would be negative 5. A to the negative 5th power. All right. Number 2. What did we say? Goes on the G if we see that it's just G with no exponent. It has an exponent of 1. So this would be G to the 17 minus 1. What's 17 minus 1? 16. Okay. Now that we've refreshed our memory on our product rule and our quotient rule, let's move on to power of a power and the zero power property. So first, copy this down. How can I find the power of a power? It sounds more complicated than it is. Power of a power. To find the power of a power, multiply the exponents. And like yesterday, I want you to underline this last part here. Power of a power, we are going to multiply the exponents. What does that look like? I want you to copy this down right here. I'll even write it out to decide what I want you to write. 5 to the 2nd power is in parentheses with a 3 outside the parentheses. Whenever we have some kind of a term with a power with an exponent inside the parentheses and then another exponent outside the parentheses, we are going to multiply the powers together. So that would be 5 to the 2nd power to the 3rd power. We multiply 2 times 3. It would be 5 to the 2 times 3, which is 5 to the 6th power. Okay? Let's practice that. So here I have G to the 9th power in parentheses to the 6th power. What do? I multiply the powers. 9 times 6. What is 9 times 6? I should get G to the 54th power. Call that example 1 in your notes. Everybody should write that down. So I multiply the exponents. 9 times 6, I would get G to the 54th power. All right, example 2. I have S to the 9th power raised to the 5th power. What do I do with those exponents? I'm going to multiply them. So S to the 9 times 5. What is 9 times 5? 45. So in IXL, I would type S, then I would click this button, type 45, press enter. Again, what is this called? This is called power to a power. All All right, try this one on your own. This is example 3. K to the 8th power raised to the 2nd power. What do we get? We multiply the exponents, so 8 times 2, that's going to be K to the 16th power. Okay? Power to a power. So now I want us to look at what we notice is happening. We have 4 to the 3rd power is 64, 4 to the 2nd power is 16, 4 to the 4th power is 4. What happens each time I go down? Okay, think about that for a second. Now look over here. You don't have to copy this down. I just want you to look. 10 to the 3rd power is 1,000. 10 to the 2nd power is 100. 10 to the 1st power is 10. So what do you think we would get if we got 4 to the 0 power or 10 to the 0 power? Let's first look at this column. When I go from number to number here, what is happening? I am dividing by 4. Dividing by 4. What would I get if I divided 4 divided by 4? That would be 1. I want you to write this down. 4 to the 0 power equals 1. Alright, similarly, over here, 1,000 to 100, 100 to 10. 1,000, what am I doing to it to get to 100? I'm dividing by 10. 100, what am I doing to it to get to 10? I'm dividing by 10. So what do I do to get 10 to the 0 power? I'm going to divide this by 10. What is 10 divided by 10? 1. Copy that down. So what do we think? If we know 4 to the 0 power equals 1, if we know 10 to the 0 power equals 1, what kind of a assumption can I make, or a prediction? Okay, what is the zero exponent property and how can I prove it? We just proved it. Copy this down. Based on what we know about division of exponents with the same base, we can prove that any number raised to the 0 power equals 1. I want you to copy all of that down. And then I want you to underline where it says, hello, wake up. Underline where it says any number raised to the 0 power equals 1. Underline, I'm going to fix it too. Any number, really. Any number, I'm just going to highlight over it, raised to the 0 power equals 1. Underline that part, but copy the whole thing. There we go. Finally. This is very important for you to know so that we can do these last problems. This is the zero exponent property. Any number raised to the 0 power equals 1. All right, let's try an example. What is negative 3.6 raised to the 0 power? Well, based on our rule that any number to the 0 power equals 1, is this any number? Yep. So any number raised to the 0 power equals 1. Okay? Memorize it now. Any number to the 0 power equals 1. All right. Let's practice a little bit of division. Let's refresh our memories that the quotient rule said when we divide and we have the same base, we subtract the exponents. Now here I see coefficients that I have to deal with. I'm just going to do 18 divided by 18. What is 18 divided by 18? That's 1, so I can actually just cancel them out or just write a 1. Now I'm going to subtract the exponents here because I have the same base x. What is 20 minus 20? What's 20 minus 20? That is 0. Ooh, x to the 0 power. What did I just say? What's that rule I told you to memorize? Any number to the 0 power equals 1. So x to the 0 power equals 1. Alright, I don't even remember what example we're on. I think this is 4. So then let's call this example 5. Do this with me. Alright, starting with the w's. I'm dividing, so I have to subtract the exponent. So w to the 8 minus 8 power, and then z to the 15 minus 8 power. All right, what is 8 minus 8 going to give me? 0. So, yeah, w to the 0 power. What is 15 minus 8? 7. Okay, what do we know w to the 0 power is the same as? Remember what we said over here. Anything to the 0 power equals 1. So I can just say that's 1z to the 7th power. If I multiply that times 1, it just stays the same, z to the 7th power. All right, couple more examples and we'll be done. Call this example, what is it? 6, example 6. Example 6. Oh. Okay, we're going to start with the numbers out here on the outside. What is 9 divided by 3? 9 divided by 3 is 3. All right, now let's do the x's. X to the 5th power divided by x to the 2nd power. So we're going to do 5 minus 2. And then the y's, we have to do y to the 12th divided by y to the 12th. We subtract the 12th. All right, 3 is just going to stay the same. What is 5 minus 2 here? 5 minus 2, we will get x to the 3rd power. And then for the exponent on the y, what's 12 minus 12? That's 0. Now what did we say about anything to the 0 power? It equals 1. So this equals 1 times 3x to the 3rd power. It just stays the same. 3x to the 3rd power. All right, last thing. What is x to the 0 power? Anything to the 0 power equals 1. So this is like saying 5 times 1. What is 5 times 1? 5. Alright, so our exponent rules from today, power to a power. When you have a power to a power, you multiply the exponents. And then the 0 exponent property, when you have an exponent of 0, it equals 1. You have an IXL, a couple IXLs actually on your IXL list to work on, complete the spiral review, and then work on your missing assignments. If you need help, raise your hand.